Hello class, welcome to today's lesson, which is rules of differentiation part 1, because there is going to be a part 2, so let me make it explicit. Okay, so we're going to learn today the rules to get the derivative of a sum of functions, a product of functions, and a quotient of functions. So let's first go down to the first one. Okay, the sum of functions. Well, the derivative of a sum of functions. So suppose that you have a function h, which is given as the sum of two other functions in this way. H of x is equal to f of x and plus g of x. Then, as I've told you before, because this one we have already used this one, the derivative of h will be simply the derivative of f, in this case, plus the derivative of g. So basically, the derivative of a sum of functions is the sum of the derivatives independently. And it doesn't matter how many functions you have, okay? If you have any number of functions in here, it's going to be the same. It's going to be the sum of the derivatives of such functions. So let's see one example of this. Suppose that we have the following function. Suppose that I give you f of x equals x squared plus 3 times the sine of x. So in fact, f is the sum of two functions. As we can see here, this is one function. This can be considered as one function plus what can be considered as another function. You see? So f prime of x will be equal to the derivative of this one plus the derivative of this one. What is the derivative of this? It's very simple, 2x plus the derivative of this. First, you have a constant, right? Remember that the derivative of a constant times a function is the constant times the derivative of the function. And the derivative of sine of x is cosine of x. So basically, we are done. F prime of x is equal to 2x plus 3 cosine of x. If you notice, this is the derivative of this, and this is the derivative of this. So it's basically just adding the derivatives independently of each of these two functions. So that's how it works. This one's simple. Now let's go to the second rule. Rule number 2 is the derivative of a product of functions. So suppose the following. Suppose that I give you a function h such that it is the product of two functions, f of x times g of x. Okay, so what's going to be the derivative of h? Is it going to be simply the multiplication of the derivatives, just like in the addition? If the derivative of the addition is the addition of the derivatives, does that mean that the derivative of a multiplication of functions is a multiplication of the derivatives? No. In this case, this is not going to work. Okay? When you demonstrate how to calculate the derivative of a product of functions, what you get is the following formula. H prime of x will be equal to the first one, what I mean is the first function, times the derivative of the second, which is g in this case, plus the second function without the derivative, you see, times the derivative of the first one. I'm going to repeat that. If you have a product of functions like this, and you want to differentiate, okay, this product, what you do is you take the first one, you multiply it by the derivative of the second one plus the second one times the derivative of the first one. Okay, so if you want to, like I've been telling you, you have to memorize these rules. So the way in which most people memorize these rules is kind of like in a song or something like that, like with words. For example, the way I memorize these formulas is this: the derivative of the product of two functions is the first one times the derivative of the second one plus the second times the derivative of the first. You can just say that if you want. The first times the derivative of the second plus the second times the derivative of the first. That is enough. And you have to say that as many times as necessary in order uh, for that information or that rule to be put into long-term memory. Okay, so that's how it works. Now let's put it to use. Suppose that I give you the following function: f of x equals x squared times the sine of x. If you notice, this function f can be understood as the product of two functions, one of which is this one, x squared. This can be considered as a function, and the other function is sine of x. You see, so it has this same shape. So we can differentiate f by applying this rule. So f prime of x will be the first function, so I just write it down like so, the first one, times the derivative of this, of the second. And I'm going to show you another notation that is very common in mathematics. If you want to differentiate a function, if you want to find the derivative of this function in particular, you can use this operator. It's called the derivative operator, which is known as it's written as a d and then a little x in here, and then you're gonna put inside the function that you're trying to differentiate, like so. So let me tell you how this is read. The first function times the derivative of the second. You're gonna read this as the derivative of the second function. Now, why the x in there, I'm gonna tell you a little later, okay? The complete reading of this is the derivative with respect to x of this function. But if I say the derivative with respect to x, that doesn't ring a bell to you right? With respect to x, that doesn't mean anything for you yet. So if you want to just read this as the derivative of this, that is perfectly fine, and it's called the derivative operator. What this operator does is it gets the derivative of this function. Okay, let's continue. Plus, what does my rule say? Plus the second function, as you can see, which is sine of x, times the derivative of the first. So I write the derivative of my first function, which is x squared. I can do this first. I mean, you can also do it directly, right? But I wanted to show you this because it's gonna be necessary in a moment. When things get complicated, this operator comes in handy. So now that I've written this, let me actually calculate the derivative of this and the derivative of this. So let's continue. X squared times the derivative of this, which is going to be cosine of x, according to the formulas that I gave you yesterday, plus sine of x times the derivative of this function, which is 2x, as we know. And we are done, guys. There's nothing else to be done. And we have calculated the derivative of f following the rule of the product, okay? And I'm introducing you to this new operator, the operator derivative, okay? When you write something like this, what this means is get the derivative of this function. So the result of all of this is going to be 6x. Now, example, the derivative of this function, get it, okay? So it's gonna be minus 2x to the minus 3, according to my rule of how to get the derivative of this type of function. So you see, this is how this operator works. I'm gonna give you another example of product, a little more complicated. You see, you have to understand that these rules can be iterated. And what that means is the following. Look, I'm going to give you f of x equals 3x squared times sine of x times e of x. So now, as you can see, f can be understood as the multiplication of three functions, one of which is this, the next is this, and the final function is this. So it's a triple multiplication. So what are we going to do? Because a moment ago, the formula that we had only, well, let me write this. The formula was this, right? If h of x is equal to f of x times g of x, then h prime of x is the first times the derivative of the second plus the second times the derivative of the first. So this formula only seems to be applicable to the product of two functions, 1 and 2. But now I have 3, 1, 2, 3. So what do I do? Okay, what you have to do is consider the following. You can associate. For example, I can say, and there is nothing wrong about this, I can consider all of this as a single function, you see, and all of this as a single function, you see. Or I could have done the other way around. I could have considered only this part as a single function and the product of these two as another function. And once that I have this association, I can apply the rule. What's it going to be? We're going to have f prime of x equals the product of this function times this function. That's what f of x is. So f prime of x is going to be equal to, let's start, the first function, which is all of this, times the derivative of the second function. So I do this, the derivative of the second function, plus the second function times the derivative of my first function, which is all of this, 3x squared times sine of x. You see? And we have to continue, right? We're not finished. This one is a little complicated, and it's kind of tedious, getting the derivatives of functions. It's not fun. Okay, so now what do we have to do now? Well, we have to get the derivative of this function and get the derivative of all of this function inside here. So let's do it. The derivative of e to the x is itself. That's the only function that for which its derivative is itself. Okay, it's a very curious property about the exponential function. Its derivative is itself. Okay, so we're done with the first part. All of this done. There are no more derivatives to find. Plus e to the x, which is this factor, times the derivative of all of this. But if you notice, all of this is a product itself. So we have to apply one more time the rule for the product, which is this rule, right? So you can see how this can get very, not complicated, but very tedious. That's the word. It's very laborious, very tedious. So now the derivative of all of this. My suggestion, guys, my suggestion is, if you want to isolate this problem and I don't know, like do it somewhere else, like bring this problem over here on its own, like stop this for a moment. Let's make a pause right here. Bring this problem, which is a problem on its own, finding the derivative of this product of functions, bring it over here. Okay, perform it, get the result, and then plug it back in here. That is a very common technique in mathematics, and I like it. I use it a lot. It's just very common. So let's do it. The derivative of this product is going to be equal to the first one, the first function, times the derivative of my second function, which is this, and I'm gonna do it directly. The derivative of sine of x is cosine of x, plus my second function times the derivative of the first function, which is going to be 6x. You see, and I'm done. I have already calculated the derivative of all of this function, which is itself the product of two functions, and therefore I had to apply the rule for the product of the derivative. Now, the rule for the derivative of the product, I mispronounced. So now that I have the result, I come back to my original problem, and since all of this is equal to all of this, there, you see, therefore I just paste it. All of this thing is all of this, so I'm just gonna paste it like so, and I'm done. Okay, why am I putting brackets, guys, in here? Did you notice? Why am I writing brackets in there? Why is it necessary? Because if I don't do that, look at this. What I'm saying by writing this is that e to the x only multiplies this. E to the x times this, and then plus this little part. Okay, and that would be incorrect. Why? Because if you notice in this part in here, this function e to the x is multiplying all of this derivative. It's multiplying the derivative of all of this. And since the derivative of all of this is all of this thing, you have to put it in between brackets like so, in order to establish that e to the x is multiplying all that is inside these brackets. And we're done. I mean, if you want, you could multiply e to the x times these two, and then plus e to the x times this term, okay? But I'm gonna leave it like so. So you see, these calculations can be, they're not complicated, but you can make uh, mistakes very easily, because these calculations imply a lot of they may need a lot of steps, and even just a single mistake is enough for you to get these things wrong. Okay, so you have to proceed little by little, very slowly. Try to use Try to make use of the operator, like I told you, if you think you need it. Okay, if not, you don't have to. And I think I'm gonna make a pause right here because I don't want to overload you with so much information. The next rule, which is in the rule for the quotient, we're gonna see that in the next session, okay? Or for homework. I'm gonna leave that for homework. But in the meantime, that's it. Let's start to work on getting the derivatives of addition of functions and products of functions. That's all we're gonna do for the moment.